Hello everyone. Today we are in the mathematical combinations of discrete Fourier series. Here we have the formula of IDF, which is represented by this. Now move to the next. Today we will discuss about some mathematical transformations. In our previous slide we have seen this math, which is to find the DFT sequence of this one and find the IDFT of this. Here we need to apply DFT to convert the x of n into x of k, because x of n is the time domain and x of k is the frequency domain. And here we have yk, that means it is the frequency domain and we need to transform it into the time domain. That is why we have used the IDFT. Here we have the value of n is 4, and first of all we started with the x of 0 by applying the formula of DFT, which is this one. For here we have the value of n is 4, so n minus 4 is 3 here, and n is equals to 0. For here we have the value of x of 0, 1, 2 till the 3, and here we have the result is 2. For x of 1 we applied the same formula and have the result. As usual we have applied for x of 2 and x of 3. In last we have the result, which is xk equals to 2, 1 minus j, here is a j, 2, 1 minus j, 0 and 1 plus j, which is the result of DFT conversion. Now here we are applying IDFT. For y0 we have applied the formula of IDFT, which is this one, and in the result we have for y0 we have this value, for y1, y2, y3 and so on. Lastly we have the result is this one is for y0, y1, y2 and y3. Here we have the value of time domain. I hope you have already understand why we use the DFT and IDFT. Here is also a mathematical term of plotting. Here we have the value of x of n, which is the time domain, and we need to convert it into the frequency. In the condition we have, if we have the value from 0 to 2, we will make it 1, and otherwise it will 0. That means the graph will look like this. From 0, 1 and 2 it will be 1, and otherwise the value will be 0. Here we have put the formula of DFT and calculated the value for x of 0, x of 1, x of 2 and lastly x of 3. So here the value of ours is, which will looks like this, which is 3, 1, 1 and 1. Here this one is the angle of x of k. How we generate the angle? In this section we can draw the diagram, which will looks like this. Here we have 3, so we put the value 3 in this diagram, and next one is a 1. Next value is also 1 and another value is also 1. If we draw this, the output will looks like this. And if we want to generate the angle diagram, this will looks like this. It started from 0 to the minus pi by 2, and then it will move to 0 again, then it will 0 here, and next for 3 it will again plus pi by 2. Now here we have taken n equals to 8. That means in this previous section we do the math for n equals to 4, and now it is n equals to 8. All the remaining conditions will be same, and lastly the output will looks like this. Here the value is this and the angle will looks like this, and this one is the diagram which is similar to the previous one. Here we have lots of math on DFT. For this n input, we need to again convert them into the frequency domain. And IDFT, applying this, here we have the xk, which means it is the frequency domain, and we need to convert them into the time domain. That is why we have applied the IDFT. That's for today. Thank you.